Sometimes atoms need to form more than one bond in order to get to a stable octet. In this case, we have two oxygen atoms. Each oxygen atom has 6 valence electrons. So we start off by drawing the dot diagrams for each oxygen atom. The two unpaired electrons are going to come together and form a single bond, and then these two single electrons also come together and form another bond between the oxygen atom. So by forming this double bond, we now have 2, 4, 6, 8 electrons on each of the oxygen atoms. Instead of leaving it as just sets of 2 dots, what we can do is take those away, and each set of 2 dots is represented by a line. So now we have a double bond between the two oxygen atoms, each of those lines representing 2 atoms, and 2 lone pairs on each of the oxygen atoms. If we have nitrogen instead of oxygen, every nitrogen atom has 5 valence electrons. So if we make the dot diagram for nitrogen, we can see that each nitrogen wants to form 3 bonds. So these 2 electrons come together to form the first bond. These 2 come together to form the second bond, and these 2 come together to form the third bond. So now we have each 2 dots gets a line, a triple bond between the nitrogen atoms with 1 lone pair on each of the nitrogens. If we have more than 2 atoms, we need to know which element is going to go in the middle. Usually it is the least electronegative atom that is going to go in the middle. So if I have CO2, carbon has a lower electronegativity than oxygen, so carbon goes in the middle with oxygens on either side. Carbon has 4 valence electrons, so 4 dots. Each oxygen has 6. So the oxygen wants to form 2 bonds. So here we have the carbon and the oxygen, a single dot and a single dot pair up to form a bond. Single dot and single dot pair up to form a bond. Single dot form up to pair a bond. And single dot pair up to form a bond. So now we have a double bond between the carbon and each oxygen, and 2 lone pairs on each oxygen. Now, we need to remember that for covalent compounds, we can't just add more atoms like we did with ionic compounds, because we're being told what the formula is here, not predicting it. So I know that carbon monoxide exists, which is carbon with an oxygen. And the carbon has 4 valence electrons, and the oxygen has 6. So when I start forming the bonds, I can see that I have a single dot here and a single dot here. Those can pair up to form a bond. I have a single dot here and a single dot here that can pair up. At this point, oxygen doesn't have any more single dots that can form bonds. The carbon right now only has 6 electrons on it. The oxygen has the 8 that it wants. So what's going to happen here is the oxygen is going to take both of its electrons from one pair and bring it down to form another bond. And then the 2 electrons that are left on carbon pair up to form a lone pair. So I end up having a triple bond between carbon and oxygen with a lone pair on each. This is called a coordinate covalent bond when both electrons from one of the bonds come from the same atom. It happens a lot with polyatomic ions. For example, NH4+. The nitrogen is going to go in the middle with hydrogens around it. Nitrogen has 5 valence electrons. Each hydrogen has 1. But this is the ammonium polyatomic ion. It's NH4 with a positive charge. So when it has that positive charge, that means that an electron has been lost. And the electron is going to be lost from the hydrogen because it has a lower ionization energy than nitrogen. But here we can see a single dot from nitrogen, single dot from hydrogen are going to form a single bond. Single dot from nitrogen, single dot from hydrogen are going to form a single bond. Single dot from nitrogen, single dot from hydrogen form a bond. And then here I have the 2 electrons that are from the nitrogen are going to form a bond between the nitrogen and hydrogen. So we have a coordinate covalent bond being formed between the nitrogen and the hydrogen. So we need to remember that every atom wants to have a total of 8 electrons, except for hydrogen, which only wants 2. And where we have single dots on the dot diagram, we're going to be forming a bond. But sometimes we might need a lone pair to give both of those electrons to form what's called a coordinate covalent bond. Once that coordinate covalent bond has formed, it is no different than any other bond.